Welcome back. In this video, I will explain you how Quicksort algorithm works and also compute its complexity. Now, the overall idea is like this. You have a list of elements and we say that this is a whole list. The algorithm selects one element from this array and tries to find out the proper location of that element in this array. For example, these are the 12 locations and the algorithm will try to find out the proper location of 44. Now you can see that 44 is present in the 0th index or the first position, but actually it should not be there because 33, 11, these are lesser than 44. So definitely after 33 and 11 and some other numbers over here, 44 will be located, right? The proper location of 44 after scanning the whole list will be at 4. So if I demand that 44 is in the correct location in this list, then all the numbers on the left hand side will be lesser than 44 and all the numbers on the right hand side will be greater than 44, isn't it? Since 44 has correctly placed at 4, then we got a sublist on the left hand side which we call sublist 1, and on the right hand side we got sublist 2. Now we apply the same technique to each of these sublists, right? For example, let us take sublist 2 and we try to find out the proper location of this element 80. So here we go with the locations. We have already got 44 over here in the correct position, and on the left hand side these are the numbers lesser than 44. Now after scanning this sublist 2, we find that 9 is the correct position of 80. So the numbers lesser than 80 but greater than 44 will be here, isn't it? And on the right hand side of 80, the numbers higher than 80 will be here. So we got a sub-sublist 1 on the left hand side of 80, and on the right hand side we got sub-sublist 2. You apply a similar technique for each of these sublists. You can select any sublist one by one and try to find out the location of the first element. Then it will be properly located. Then it will create 2 sublists more on its left hand side and right hand side, and you go on like this in a recursive way until you got all the numbers in an ascending order. Of course, applying Quicksort, you can go for descending order also. Now, how will you come to know that an element from this list has been placed in its correct position? Now, this is the first condition, that if you say that all the elements on the left hand side are lesser than the given element and all the elements on the right hand side are greater than the given element, then you say that that element is in correct position. This is number 1. And number 2 is, if you say that a sublist contains only one element, it will definitely go like this, that for this sub-sublist 2, you try to find out this 88. And of course, 88 will be there in its proper location at 10, and it will create a sublist on the right hand side with a single element 99, right? Of course, on the left hand side, there will be no sublist. So for 99, you don't have to run the algorithm. You can simply declare that since the sublist is containing only one element, then definitely it is in its correct position. So these are the 2 conditions you will follow to declare an element's correct position in the list, right? Now we will start with the algorithm. This is an array and the name of the array is A. These are the 2 stacks we will use. The first stack is lower, which will carry the lower index of a list, and correspondingly in the upper stack, in the same index, it will carry the highest index of that same list. Suppose, for example, you have got a list like this and you have got another list like this. So these are the 2 sublists. So for the sublist 1, you name sublist 1 and this one is sublist 2. For this S1, you have the lower index as 0 and the upper index as 4. So you can write here 0 and 4. So the 0th index of this lower stack and the upper stack is determining the range of a sublist. Similarly, The sublist 2 starts from here at 6 and ends over here at 11. So you write the lower index as 6 and the upper index as 11. And both of them should be in the same index. It should not happen that 0 is the lower index of one sublist and its upper index is somewhere here or here. It will not go like that. We have two scanning business in this algorithm. To scan means you have to start from the right towards the left and compare the element with which you are trying to compare. For example, if you want to start with 44 and you want to place the 44 in the correct position in this list, then you have to compare this 66 and 88 and 22 and all those stuff from the right hand side to the left hand side, and there is a condition how far it will move from right towards the left, and after stopping what you should do, everything is written over here. After this, it will start scanning from left to right. That means it will start comparing from left to right. Okay, and there are some conditions here how far it will move from left towards right and what you should do after stopping. So everything is written over here. We will shortly discuss about this. Now let us go with the 44. So sometimes people used to say this 44 as pivot. Okay, P-I-V-O-T. So they used to say pivot. So pivot element is that element whose proper location you are trying to find out in this list. Okay, you initialize top to -1 and then you follow this pseudocode. Set top to top plus 1. That means top is at -1 now. You bring top to 0 and you set lower top to 0 and upper top to n-1. So you will write like this, n-1. We have 11 here for this specific example, but you may have a different size of list. In that case, use n-1. Okay. So our lower top, that means lower 0, will be set to 0 here, and upper top, that means upper 0, will be set to 11. Okay. So this is one-time business. After that, the loop will be running for placing the other elements in their proper places. That time, this pseudocode will not be required. Next, you go like this. Set beg to lower top, end to upper top. What is the meaning of lower top? Lower top is lower 0 and lower 0 means 0. And end is upper top. Upper top is 11. So you set beg and end to 0 and 11 respectively and get your top down. Okay, so top will be going down to -1. That means you are actually popping 0 and 11 from these stacks, right? So you set beg to 0, you set end to 11, and you take top down to -1, and then you do one more thing, that you set left to beg, right to end, and lock to beg. Okay, so left will be set to 0, right will be set to 11, and lock will be set to 0. Now I will explain actually what these variables are doing here. This green one, this beg and end, is actually dealing with the list on which you are working at present. Since we are working over the whole list, that is why beg is 0 and end is 11. When sublist will be created, at that time, beg and end will differ from 0 and 11. Okay? So beg will be dealing with the lower index of a list and end will be dealing with the upper index of that list. Right? Now, this left and right. This left will be moving from this side to this side, and right will be moving from this side to this side. So that is the scanning thing we have to do. Right? And we have lock is set to 0. Lock means the location of that pivot. Now we start with this block. Whenever you are dealing with ascending order and you have the pivot on the leftmost element of this list, then you always start from right to left. Okay? So what this block says, the first job, there's a while loop. This is the first condition. A lock is less than equal to A right. Now at present, A lock means A 0. Lock is 0. So here it will be 44. Right is 11. So A right is 66. It is true. There is another condition here. Lock is not equal to right. Now lock is 0 here and right is 11. So this condition is also true. Then we get inside this while loop. Right is set to right minus 1. That means we want to move the right from the position 11 to position 10. So every time you have these two conditions true, you move right one step backward from the right towards the left. Right? So we have right equal to 10 now. Now this while loop goes. You again compare this A lock, that is 44, with A right. Now A right is 88 and lock is not equal to right. So we get inside again and execute this statement. Right is set to right minus 1. So it comes down to 9th position. Okay. Now again we compare 44 with A right, that is 22. Now this condition does not work. So your while loop stops. Consequently, your movement of right towards the left stops here. Now we have the B condition here, that if lock equal to right, then you return from this block. And this indicates that you have found the location of the pivot in its correct position. Okay. Now you see that lock is not equal to right. So right is 9 and lock is 0. So B does not work. We straight go to C. If A lock is greater than A right, yes it is, that is 44. 44 is greater than 22. Then we interchange A lock and A right. So we interchange 44 and 22. So it goes like this. 44 comes over here and 22 comes over here. Clear? Now you see that your pivot has gone to this location 9. Now how will you come to know the new location of this pivot element 44? You follow the right because it has taken the right's index, right? So bring lock 0 to lock 9. So that is why it is written set lock to right. Now after this, what we should do? We go for scanning from left to right. That means this block. Okay, so we come to this block and we start scanning from left to right now. That means from this side to this side. Now the element to be moved is left. So you see A left, that is 22, and A lock, that is 44, is compared. For it's true, and left is not equal to lock. So left is 0 and lock is 9. So it is also true. So we execute this statement. Left is set to left plus 1. So left will move from 0th index to 1st index. Next you compare. A left is 33 now and A lock is 44. It's true. Left is not equal to lock. It's also true. Then move left to left plus 1 so that left will come at 2. Again you compare. A left, now it's 11 and 44 is here. So 11 is less than 44. So bring left to this 3rd position. Now you get A lock as 55 and you have 44 over here. Now this 55 is here and 44 is here. So this condition fails. So your while loop stops and left is static now at 3. Now we have to check for B. Here we find that left is 3 and lock is 9. So B does not work. So we go for C. Here we see that if A left, that is 55, is greater than A lock, that is 44, then you interchange A left and A lock. That means 55 will be coming over here and 44 will be coming over here, right? So 55 comes over here and 44 will be coming over here. Now you see that 44, your pivot has gone to this place and it has taken place where left is standing. So bring lock from the 9th location to the 3rd location like this. That has been written over here. Set lock to left. And then you go for scanning from right to left again. So come to this block. Now go for comparing A lock and A right. So what is A lock? Here that is 44. And A right is 55. Yes, it's true. And lock is not equal to right. It's also true. then bring right backward 1 position. So right is at 9 now, it will come to 8. Again you compare A lock, that is 44, and A right, that is 99. So this will be 99. It is true, lock is also not equal to right, so bring right 1 step backward. You compare again 44 and 60. 44 is less than 60. Move right 1 more step backward and right is at 6 now. Now you compare 44 here and A right, that is 40 now. So 44 is greater than 40. So this condition does not work. So we stop the loop and right gets static here at 6. We go for B. If lock equal to right, then return. There is no question of returning now because lock is 3 and right is 6. So we go to step C and there we find A lock greater than A right. Then you interchange A lock and A right. So A lock is 44, A right is 40. So you interchange and 44 comes over here and A lock comes over here. Now your pivot has gone over here. So follow the right to bring the lock from 3 to 6. And after doing this thing, you move from this block to scan from left to right again. So we come over here, then we have A left. What is A left? It is 40. So you write here 40. A lock is 44. So 40 is less than equal to 44 is true. Left is not equal to lock, so we get inside and set left to left plus 1. So left is at 3 now. Left will move to 4. Now A left is 77. So we write here 77 and we have 44 over here. It's not true, so we stop the loop and go for B. It's also not true, then we go for C. A left is greater than A lock. Yes, 77 is greater than 44. So we write here 77 greater than 44. And we interchange A left and A lock. So 77 will be coming over here and 44 will be coming over here. You set lock to left. That means lock is at 6. It will come at 4. And we start scanning from right to left again, this block. We have A lock as 44 and A right as 77. So it's true. Lock is not equal to right. It's also true. So we get inside to move right 1 step backward. So right will come at 5. Here the loop goes again. A lock is 44 and A right is 90. So still it is working. So we move right 1 step backward. So right is at 4 now. Now we say that this 44 is for A lock and also for A right. So we write here 44. So 44 is equal to 44. So it is all right. But here you say this condition. If lock is not equal to right, then you move right towards the left. Now you say that lock and right, both of them are in the same index 4. So this while loop will not work now. Then we go to step B and we find that if lock is equal to right, then return. Now you say that lock and right, they are both equal to 4. So we return from this cycle. And this indicates that 44 has been placed in the correct position in this list. You can check it out. On the left hand side, you see that all the elements are lesser than 44. And on the right hand side, all the elements are greater than 44. We mark this 44 with a green and then we continue applying the algorithm. Now you can see that there are 2 lists created. One is this one on the left hand side. So we call it sublist 1. And on the right hand side, we call it sublist 2. So how will you define the sublists like this? For that, you have a little piece of code here. If big less than equal to lock minus 1. Now what is big? Big is 0 and lock minus 1 is 3. So big is less than lock minus 1 is true. Then what to do? You set top to top plus 1. That means you increment top. Top comes to 0. And then you set lower top to big. That means lower top is lower 0. Here you put 0 over here. And upper top to lock minus 1. That means lock minus 1 is 3. So your sublist starts from 0 and ends at 3. So this is the indication of a sublist. The lower stack carries the lower index of a list and the upper stack is carrying the upper index of sublist. So this is sublist 1. We go for sublist 2 here. You see that the starting index is at 5. And how will you find out the starting index? You add 1 to LOC. So you say that if LOC plus 1 is less than end, now LOC plus 1 is 5, end is 11, then you set top to top plus 1. So increment top over here. So top comes at 1, and you set lower top with LOC plus 1 and upper top with end. So lower top will be 5 and upper top will be 11. So this is another list. So your stack is actually giving you the list and their indexes. Now after setting this sublist, we have to pop from the stack to start working with the quicksort algorithm again. And we execute this statement, that is set big to lower top and end to upper top. Lower top is 5 and upper top is 11. So this 5 will be set to big and the upper top, that is 11, will be set to end. Since we have popped this 5 and 11, so we pull down this top to the 0th index like this. So there is only one sublist to be attended, and we are now ready to work on this sublist with the big 5 and end 11. So you have to set left equal to 5 and right equal to 11 by this statement, and this LOC is set to big, that is this. That means you are trying to put this 90 in its current position in this sublist 2. So this is your pivot. We start scanning from right to left as before. So you see that A LOC is 90 and A right is 66. So you see that this while loop does not work. So right is staying at 11. Okay, LOC is not equal to right. So we go to step C and we find that A LOC, that is 90, is greater than A right, that is 66. So we interchange A LOC and A right. So 90 will be coming over here and 66 will be coming over here. This time there was no movement of right variable and directly the interchange has taken place. Right. Now we set LOC to right, this one. So LOC comes over here at 11 and then we move to this block. Now we start scanning from left to right. So what is A left? 66. And what is A right? 90. So 66 is less than or equal to 90. Left is not equal to LOC. So we move left forward. So left comes over here at 6. Again, we check for this A left, that is 77, and 90 is here. So we move left to this place. 60 is less than 90. Left is not equal to LOC. So we move left over here. And now we got stuck because 99 is greater than 90. That means A left is greater than A LOC. So the while loop stops. Left got stagnant at 8. We find B that it is not true. So we go to C, we interchange. So 99 comes over here and 90 comes over here. So your pivot is at 8 now. So you bring LOC from 11 to 8. And then you start scanning from right to left. That means this block. You find A LOC, that is 90. You find A right, that is 99. So it's true. LOC is not equal to right. It's also true. So bring back right one step backward at 10. Here you find A LOC as 90 and A right as 88. So you find that this is not true. So you stop over here. You find B as false because LOC is not equal to right at present. Then you go to C and you interchange A LOC and A right. So 90 comes over here and 88 comes over here. You set LOC to right. LOC is at 8 now. It will come to 10 and then you start scanning from left to right on this block of code. A left is 88. A LOC is 90. It's true. Left is not equal to LOC. Is also true. So bring left forward one step. That means left is at 9 now. You compare A left, that is 55. This one is 55. It is less than 90. So bring left forward. Now you see that left and right both are same. So your while loop stops. And now your B statement works. If LOC equal to left, then return. This means that the pivot has got to the correct position in the list. That means your 90 is in the correct position at 10. So you make it green. So we have got two elements, 44 and 90, in their correct position. Now after getting this 90 in its correct position, we have to find out the sublists. So we can see the sublist will be looking like this, that it will be starting from 5 and ending at 9, that we call sub-sublist 1. And this one is sub-sublist 2, which is a starting index at 11 and the ending index is also 11, right? So you see, beg, which is 5, less than LOC minus 1, that means 9. So if 5 is less than 9, then you set top to 1, that means top comes over here. You set lower top with beg. So beg is 5, so 5 will be coming over here. And you set upper top with LOC minus 1. That means 9 will be coming over here. It's fine. Now on the right hand side, we have already discussed about this, that if you find one element in a sublist, then you will come to know that that element is in correct position, so there is no need to run the algorithm. So here we find that in this sub-sublist 2, there is only one element, 99. So 11 is the lower index as well as the upper index. So we do not need to run the algorithm here. So you see here, if LOC plus 1, that is 11, is less than end, it is not less than equal to end, it is less than end. So end is 11 and LOC plus 1 is 11. So this condition will not work. This is the check for handling single element in a sublist. So we declare 99 is in correct position with this green box, and we again go for executing this statement. Set beg to lower top and end to upper top, and top will go down by 1. So beg will be 5, this one, end will be 9, this one. That means these have been popped. So top goes down and we start the algorithm within this range from 5 to 9. So left is here at 5, right is here at 9. We set LOC to 5. Now you can start from this side. You scan from right to left. Right is 9 over here. 66 is greater than 55. So right will not move. They will be interchanged. So 66 will be coming over here and 55 will be coming over here. And your LOC will be here, isn't it? After that, you will move from left to right. That means left is 5, right is 9, LOC is 9. So A left is 55, A LOC is 66. So move left from here to here. So left will be standing at 6 now. So in this way, you carry on with the algorithm and your 66, that is a pivot over here at this moment, will find its correct position and it will create two more sublists in between. So I will stop here and I will go for computation of the complexity. Now here we have a table. These levels are actually those cycles, and for each cycle we have to get the sublists produced and the number of elements placed. Suppose this is the list and we have the M is in correct position, creating two sublists. That means in level 1 you have two sublists produced and you have one element placed in its correct position, right? Now in level 2 you have 4 sublists and you have 2 elements placed. In level 3 you have 8 sublists produced and 4 elements placed. In this way you go on like this, then you will have find 16 here and you will have 8 elements, you will have 32 sublists and you will have 16 elements over there and you have 64, you have 32 like this. So you can see that there is a pattern that is being followed, right? So you go for this computation. First I say that what is complexity? You find the number of comparisons required to sort n elements in the list. Okay? So how many comparisons do you need? That is the question. So that is the complexity. Okay? So each level may need a maximum of n comparisons, right? Now the point is that how many levels do you need? So that we have to compute. So you see that any kth step, it places 2 raised to k minus 1 elements. For example, if you have a level 1, then it is placing 1 element, right? So level 1 means 2 raised to 1 minus 1, that means 2 raised to 0, that is 1 element. So this is the figure. For 3, 2 raised to 3 minus 1, that means 2 raised to 2, that is 4. So here it is. So you have a map between this level and the number of elements placed, right? So you find that this number of elements will be placed at the kth reduction step, right? So to place 2 raised to k minus 1 elements, you write like this, you need k steps. Now you check log on both the sides with the base 2. So log of 2 raised to k minus 1 base 2 equal to log of k base 2. Now bring this k minus 1 over here in front so that it comes over here. Then the remaining part is log of 2 base 2, and on the right hand side it remains same. Now log of 2 base 2 is 1, so k minus 1 comes over here and log of k base 2 remains as it is. So you see that for placing k minus 1 elements, you need log of k base 2 steps, right? So change the k to n and you get n minus 1 element needs log of n base 2 steps. Now this is an approximation, so in place of n minus 1 you can write n. So for handling n elements, you need log of n base 2 steps, right? Now you have got the number of steps and you have got the number of comparisons for each step, maximum comparison. So you just multiply and you get this n log of n base 2 comparisons in total. This complexity is for average case. That means the list is not sorted or the list is not totally out of order. It is somewhere between these two extremes. In that case, you will have n log of n base 2 comparisons. Now see over here. Suppose these letters are there from the English alphabet and they are all in order. We take A as pivot and try to find out the correct location of this A. So we have to go for n comparisons, right? So we have n comparisons here. Okay, then A is there already. Now we take the B as pivot because this is a sublist. So we start with the B and go for comparing with all those elements over here. So we have a comparison of n minus 1. So A and B are already there. We try to find out C and we find that C is already there in its own location, but we have gone for comparison n minus 2 times. So in this way you go on like this, and at the end of the list you will find 2 comparisons and only 1 comparison at last. So if you add this thing, then you get this n times n minus 1 by 2, that is O n square. So this is the worst case. Using quicksort is a stupidity if the list is already sorted or almost sorted. In the next video, I will explain you the algorithm for towers of Hanoi in recursive mode. Thanks for watching and take care.